Okay, Assalamualaikum student. Now I will explain on the example number 4 for chapter bearing capacity of shallow foundation. Okay, so but before I explain on the solution of example number 4, so I want to explain on the parameter, yeah, so that you know what does the parameter stand for. Okay, because sometimes usually normally in the exam, yeah, or in a normal life, we don't know in the equation, kan, you just use the parameter, right? So you have to know what is the parameter stand for. Okay, so I want to explain on the parameter that we use in the equation. Okay, for the bearing capacity, yeah. So first, number 1. Okay, number 1 is Q all, yeah. Q all equal to is the allowable bearing capacity. Alright, okay, and then for the Q allowable, yeah, there are two equation that you can calculate for QR, yeah, allowable bearing capacity. One is Q over B squared. Okay, so B is the width of the foundation. Okay, but Q capital Q is the gross allowable load. Okay, alright. And then another equation that you can calculate for Q allowable, yeah, allowable bearing capacity is Q all, yeah, equal to QU over Fs, yeah. So Fs here is the factor of safety lah, yeah. Alright. QU here is the ultimate bearing capacity, yeah. Okay, so you should familiar with all the parameter, yeah, because in the exam, yeah, especially in the exam, yeah, I didn't in the question, yeah, I just give the explanation on the parameter, yeah. So you have to know what does the parameter stand for, yeah. So you can use in your equation for the solution. Okay, so another Q is the Q, small Q, yeah, is the effective surcharge, yeah, CHARGE. Okay, effective surcharge. Okay, alright. Okay, so you have to familiar with all the parameters, yeah. Alright. Okay, so now let's proceed to the solution, yeah, for example number 4. Okay, so example 4, as a square foundation, yeah, B times B has to be constructed as shown in the figure below, yeah. Alright, so assume that gamma is equal to 16.5 kilonewton per meter cube. Okay, and then gamma saturated, yeah, is 18.55 kilonewton per meter cube. And the friction angle, free prime, equal to 34 degree. Okay. And then df is the depth of the foundation. Okay, here. Alright. df is 1.22 meter. Okay. And d1 here, d1, the groundwater level, given is 0.61 meter. And then the gross allowable loads, Q, capital Q, or with factor of safety 3 is 667.2 kilonewton. Okay, and determine the size of the foundation. Okay, use the general bearing capacity equation. Okay, so the long equation, is the general bearing capacity equation. Okay, so for the solution, okay, alright, first you have to calculate for, okay, first you have to know what is the general ultimate bearing capacity equation, okay, so the equation QU equal to C prime and C F CS F CD F CI plus Q and Q, okay, F QS F QD F QI, alright, plus half gamma B and gamma F gamma S F gamma D F gamma I. Okay, so the long equation, this the general bearing capacity equation is the equation in the exam. So the equation will be given to you. Alright. Okay. So this equation will be given in the exam. Alright. Okay. So now, first you have to calculate for the Q allowable, equal to gross allowable load QR over B squared. Okay, so it's given in the equation, gross allowable loads, is 667.2, okay, kilonewton over B, so B you have to the question want you to find what is B, so B square, so this kilonewton per meter square, so indicate as equation 1. Alright, okay, and then this is the vertical loading, so and the C, prime is 0, given in the equation here, the C prime is 0, so when the C prime is 0, so all this one is equal to 0 lah. Alright, okay, and then you have to calculate for another one, Q allowable, using this equation, Q allowable equal to QU over FS. Alright, so QU is this one lah, general bearing capacity, general ultimate bearing capacity. Alright, this one QU. Okay, so this one is 0. Okay, so 1 over 3, time this one lah, only this one and this one. Okay, so Q and Q here, this one, Q and Q, F, QS, F, QD, F, QI, plus half gamma B and gamma F, gamma S, F, gamma D, F, gamma I. Alright? Okay. Okay. Alright? So this one. And then you have to find all the parameter. Yeah, get the value for all of the parameter. Okay. So first you have to get the factor. Yeah, bearing capacity factor. Yeah. Okay. So the friction angle, yeah, phi prime given in the question is 34. Okay. Here. Alright. So refer this table. Friction angle, this one, 34. Okay. So that is the value for bearing capacity factor, and C and Q and gamma. Alright. So you substitute the bearing capacity factor in this equation lah. Okay. So for friction angle 34, okay. So NQ is equal to 29.44 just now in the table, yeah. And then N gamma, oops, why it becomes smaller? Okay. So N gamma is equal to 41.06. Yeah. Alright. From the table just now. Here. Yeah. And gamma is 41.06. Yeah. Here. Alright. Okay. And then you have to calculate all the shape factor. Yeah. And the shape factor and also the depth factor lah. Alright. The inclination factor, yeah, all of them equal to 1 lah, yeah, because it is vertical loading. Alright. Okay. So now calculate for the shape factor, yeah. So you refer to this table. Alright. Here. Yeah. This table. Okay. FQS equal to 1 plus B over L tangent B prime equal to 1 plus tangent 34 lah. Yeah. Equal to 1.67. Alright. And then F gamma S, yeah, equal to 1 minus 0.4 B over L. Okay. So 1 minus 0.4 because that B because the shape of the foundation is the square, yeah? So meaning that B L also equal to B lah, because it's square, yeah? Square, yeah. If there's a rectangular, then this one is B time L lah, yeah, the size. Okay. But in this example, the shape of the foundation is square. So B time B lah, yeah. The L become B, yeah. So B over B equal, so 1 lah, yeah. Okay, B over B equal to 1 lah, yeah. So 1 minus 0.4 equal to 0.6. Alright. Okay. Next page. And then you have to calculate for FQD equal to 1 plus 2 tangent friction angle minus time 1 minus sine V prime power of 2 df over B. Okay, so you substitute all the value into this equation. 2 plus 1 plus 2 tangent tangent 34. Okay, 1 minus sine 34. Okay, power of 2 df just now in the equation is given to you. What is the value? df is 1.22. Okay, alright, over B. Alright, okay, so now you get 1 plus 0.1 3198 over B lah. You solve this one. Okay, please check this one, the value. I hope it's correct lah. Okay, and then F gamma D equal to 1. Okay, okay, F gamma D equal to 1. Okay, alright, when you have all the value, okay, then okay, one more thing. In the equation, you have to get the Q, right? Okay. Now, in the equation, there is groundwater. Here. No. In the equation, there is a groundwater here. So, as I mentioned in the recording lecture, if there is no groundwater, so the Q is equal to gamma df. Alright. Now, when there is groundwater, so you have to refer to this one, effect of groundwater level on bearing capacity. There are 3 cases. So you can refer back to the recording lecture. Okay. So now, the groundwater fall into this, for this example, so it fall to case number 1. So the groundwater is between between 0 to df. Here, same, right? Same with the equation here. Now the equation for Q is equal to this one. So you have to use this equation to calculate for your Q. Here. Alright. So Q equal to D1 gamma plus D2 gamma saturated minus gamma W. Okay, so D1 in the equation, in the equation, this is given here. D1, this is, use different color, so easier for you to understand. Okay, so color green. So this one, D1 is give, no DF, D1. D1 is given in the equation here. 0.61. Okay. And then for D2, yeah, is DF minus D1 lah. So DF is given in the equation, depth of the foundation is 1.22 minus 0.61. Okay, so equal to 0.61 lah meter. Okay, alright. So you substitute the value for the D into this equation. So you have 0.61. Oops. Use the same color. Okay. So D1 is 0.61. Yeah. The gamma is 16.5 plus gamma 2 is 0.61 also lah. Yeah. I show you just now. So gamma saturated is given in the equation is 18.55. Alright. Minus gamma W is 9.81. Alright. So 9.81 here. So you get the answer 15.4. Yeah. Kilonewton per meter square. Yeah. Don't forget the unit when you answer the question. Okay. Alright. Then you already have all of the value for each of the parameter here. Yeah. For QU. Okay. So you substitute all the value into the equation. Yeah. So Q allowable equal to 1/3 15.4. Alright. 15.4 times 29.44. Okay. And then time 1.67. Okay. 1 plus 0.3198. Alright. Over B. Okay. And then plus half the 18.5 minus 9.81. Okay, because this one, yeah, the gamma, yeah, is the gamma saturated minus gamma W, yeah, for effective gamma, right? When there's a groundwater, so the gamma, you have to use effective gamma lah, effective unit weight, yeah. So 18.5 minus 9.81. So B time 41.06. Okay, 0.6. Okay, 1. Alright. And then you solve this one. Okay, you get 252.38 plus 265 on B plus 35.89B. Okay, so option number 3. Alright. Now number 2. Yeah, same this one lah. Q allowable. Yeah, this one is equation number 1. Okay, now is equation number 2 lah. Alright, number 2. Oops. Nampak hilang. Oops. Hilang already. Never mind. So after you get the just now equation number 1 and then number 2, and then you combine. Okay? Combine And then you combine equation 1 and equation 2. Alright, so 6/6.2 over b, yeah, power of 2. This one is equation number 1 just now, equal to 252.38 plus 265 over b, b, okay, plus 35.89b. Okay, and then you solve this one by try and error. Yeah, try and error. Okay, then you get the b equal approximately 1.3 meter. Okay, so that is the solution for example number 4. Okay, so I will upload this one in Google Classroom. Alright, thank you.